Hello, this is Dr. Aidoo of the Department of Anatomy and Cell Biology, School of Medical Sciences, University of Cape Coast. I come your way again with formation of the cardiovascular system, and this is a sequel to the earlier presentation. So we want to look at further formation processes and then appreciate it furthermore. We want to concentrate now on the conducting system. So once the heart, which is myogenic and therefore inherent in creating its own impulses, it should be able to transfer these impulses to other parts of the heart. So we want to see how this comes about. The pace as in like timing, okay, or the initiator, it develops from the sinus venosus, but this will later be found in the right atrium as the sinoatrial node because the pacemaker is absorbed into the right atrium as the sinoatrial node. So sinoatrial node as in coming from the sinus and then also situated in the atrium. So sinoatrial node, that is the position there. We remember the sinus venosus from the previous lecture, all right, which connects the vena cava, okay, and then enter the right atrium. Then this sinoatrial node will initiate the heartbeat, okay, and then transfer it to the atrioventricular node. So a node between the atrium and then the ventricles, atrioventricular node. Then the atrioventricular node, which is also known as the AV node, will pass it on to the bundle of His. His is actually a gentleman's name, okay? So Mr. His, he was a scientist that discovered it. So it is named after him. So this becomes an eponym. Bundle of His or His bundle. So the AV node and AV bundle of His develop from the wall of the sinus venosus together with the atrioventricular tissues, okay, helping in the formation of it as well. Then you realize that the bundle of His will branch or bifurcate into two portions, a left and a right bundle, which later continue towards the apex of the heart and then branches and supplies the rest of the ventricular muscles in the form of Purkinje fibers. What may go wrong? If you remember the septation of the atrium and the ventricle, we realize that because the continuation of blood flow has to be maintained, in as much as you want to septate a common chamber, you still create an avenue for the bypass for the continuous flow. So for instance, if you want to close the foramen premium, you need to create a foramen secundum to allow blood to pass through, okay? Now, eventually, you want to close all the gaps, but there are times that things go wrong. So you have issues that may not septate or close all the gaps or foramina that were created earlier on. And this will lead, when it occurs within the atrium, we call that atrial septal defect. If it occurs in the ventricle, we call that ventricular septal defect, because also in the ventricle, you remember the ventricular septum and then the membranous septum helping to close the interventricular foramen. So if that is also not done well, that is going to cause what we call the ventricular septal defects. So in this diagram, you have both of them. The atrial septal defect means a patent oval foramen. The oval foramen we know is a system that allows blood to flow from the right atrium to the left atrium in the embryo or the primitive, heart. So you need to close that. Then here you have atrioventricular septal defect because it's occurring within the ventricles. And usually that problem occurs in the membranous portion. We know that the membranous portion of the interventricular septum comes from the endocardial cushions with some contributions from the bulbar ridges. So if that is not well, constructed and formed, it's going to leave a permanent opening between the two ventricles. You don't want that to happen. We are going to mix up oxygenated blood and then deoxygenated blood. So here you have an arrow pointing through, a patent oval foramen, an example of what? An atrial septal defect. So the blood is moving from the right atrium and then entering the left atrium. You don't want that to happen. Then you have tetralogy of Fallot, which is one of the most common defect of the truncus arteriosus. Remember, the truncus arteriosus is the region of the conotruncal area where the aorticopulmonary septum divided that region into an aorta and a pulmonary trunk, right? So if that division is also not done well, because that is so intricate, and you remember how tortuous and then curvaceous it was. Okay, so you don't want that curvaceous aspect to implicate any future flow of blood, right? So unfortunately, most of the time you have issues with that as well. And this is due to an equal division of the conus or the conotruncal region. So there's an equal division of that conotruncal region that is going to give rise to the aorta and pulmonary trunk. Ideally, it's supposed to be equal, okay, equal diameters for the aorta and then the pulmonary trunk. But sometimes there's deviation of the aorticopulmonary septum more anteriorly and therefore causes one of the division to be wider than the other. So this causes anterior displacement of the conotruncal septum. You use the mnemonic IHOP, which will stand for, the I will stand for interventricular septal defect. Then hypertrophy of the right ventricle, the H here will represent the hypertrophy. O will represent overriding aorta, and then P will represent pulmonary stenosis. So this is what is happening. This aorta and pulmonary trunk is supposed to come from one structure there, the conus or the conotruncal region. But you can see that here the pulmonary trunk is smaller in diameter compared to the aorta. So the aorta is bigger and bullying that of the pulmonary trunk. So we call this overriding aorta. The aorta is overriding or bullying the pulmonary trunk by getting a bigger share of the division. This usually occurs in when a bigger brother wants to bully the younger one and they need to share a bottle of Coke. You realize that the elderly one will give the younger one a very small one, and the younger one may get angry and start crying. So it started long ago. Then due to this deficiency, it's going to cause an interventricular septal defect. Okay, so as you can see, this is a ventricular septal defect, left atrium, right atrium, and there's communication. The aorticopulmonary septum is supposed to divide the conotruncal, region all the way and then come and hit the endocardial cushions close to the ventricle, okay, the central endocardial cushion, so that it's going to be in alignment. But because of the anterior displacement, that aorticopulmonary septum moved more anteriorly and therefore missed the target of hitting the endocardial cushion, and for that matter, the membranous interventricular septum. Okay, so once that is moved anteriorly, it means that it missed the target of aligning itself with the interventricular septum. And so there's going to be deviation. So this is also going to lead to a hypertrophy of the right ventricle, in that the right ventricle pumps less oxygenated blood into the pulmonary trunk. Because the pulmonary trunk is now stenosed or constricted, it means that the ideal volume of blood that is supposed to be pumped from the left ventricle to the pulmonary region is going to be impeded because there's going to be resistance to flow. Okay, so it means that not all the blood that is being pumped or the volume of blood within the ventricle will be able to pass through the uh, pulmonary trunk. Okay, so you hear of stroke volume among others. So this is not going to cause that to be achieved, the ideal volume to be sent or blood to be sent. And because of that, the right ventricle and the muscle there will be forced to contract further and further, causing hypertrophy. And this, I always liken it to somebody who goes to the gym, a bodybuilder who wants to build his muscles. You go and lift weight. The first few days you start lifting the weight, you are not going to see much difference in your muscle buildup. You have to continue lifting the muscles for so many weeks before you start having, any positive effect. And because of that, these muscles, they are more or less lifting weight, as in pumping blood against resistance. It causes the muscles to overwork and hypertrophy or gain a lot of muscle mass. And that is what we call the hypertrophy of the right ventricle. So, in fact, the tetralogy of Fallot is interrelated. Once there is unequal division of the aorta and then a pulmonary trunk, you are going to have interventricular septal defects. And the pulmonary stenosis is also going to lead to hypertrophy of the right ventricle. So this is an image showing this big aorta and small pulmonary trunk, so overriding aorta as an enlarged ventricle, so hypertrophy of, right ventricle, the hypertrophy of the right ventricle. Right. Thank you very much. I hope this video helps.